and also the key points we have in some specific features we have inside the SOC level that we not test in the IP level. So what we new attributes we will check in the
Sir,
SOC level
your
metadata.
voice is a little bit small, sir, and you can
Hello, sorry, I didn't hear you. Can you?
yeah, yeah, I can hear now, but please talk a little bit slow, so you go too fast.
Okay, okay, sure, sure. Yeah, yeah, okay. So tell me, okay, in between also, if you feel like I'm going too fast, so you can interrupt me. Okay, sure. Okay, so let's move. So you're able to see the screen, right?
Yes, sir.
Okay. So in this flow, like you are seeing, so it is pretty much similar with the IP level, but when we go inside this the each feature, we will see some difference like from the IP level perspective. Okay. So in the top level view, we will go inside the this one SOC verification plan. So this SOC verification plan, it's different from the IP level. Like in the IP level, we generally focus on the IP feature validations. Okay, inside the IP, what how the transaction is routing inside the IP level only, how they are manipulating those and how they are generating the output data with the data. Okay, but in the SOC level, we will capture when we integrate that particular IP inside the SOC, and we how we are accessing through other components of the full chip through CPU and through, like, let's say we have some video IPs there and some PCI is there. So how we are interacting with these two IPs inside that. So we will capture some VPLAN perspective to verify this from the higher level. Okay. And next we have the SOC level test bench creation. So in the SOC level test bench creation, as I mentioned, like we have some different IPs there, like PCI and video. So those we have the single IP level verification environments there. So we integrate those IP level verification environment. We reuse those in the SOC level environment. We integrate those environment there and see how to reuse those components there. We have monitor, scoreboard, and we can use those IP level verification environment inside the SOC verification environment. So we can integrate those stuffs.
Can you speak louder?
Hello.
Can you speak slower?
Okay. So okay. So it's fast for you. Okay.
Yeah, yeah.
Sure. Okay. So till now you got the point, or I can, if you want, we can repeat.
Can you give an example based on the live project, sir? Because I cannot imagine if just say the flow like that.
I can share, but this is actually um,
Just a symbol is okay, sir. Symbol project is still okay.
yeah. So I can give you the example. Okay. Also, like if you are talking about this SOC level environment test bench creation regarding that. You have question regarding this SOC level test bench, the
Uh,
third row.
no, I mean you are explaining the verification flow of an SOC. So I mean,
Hmm.
can you give example based on a real SOC? Like
Uh,
that. So if we did SOC, we go step by
okay,
step.
I yeah, I can share you. Maybe after the meeting, I will give you those um, uh, some snippets of that. Okay, how we are creating that particular stuff.
Okay, sir. Thank you, sir.
Okay, but mainly, majorly, the thing is like in the SOC. If suppose you are creating the test bench for the SOC level and the environment class you have, so in that particular environment class, you will instantiate those IP level verification environment. Okay, so after integrating those, we can easily access those components there, like scoreboard monitor. If suppose we are verifying, let's say PCI, so we have to create some scoreboard logic inside a SOC level uh, again. Okay, but if we have the IP level verification environment is there that already have a scoreboard, so we can directly integrate in the scoreboard SOC level environment, and we can reuse those components. Okay, and after that, next we have this verification and debugging. So the major role actually in this particular thing is in IP level we generally focus on the IP features validation only, but in the SOC level we generally debug, like let's say we have some IP we are accessing through the CPU. Okay, let's say PCI we are accessing through CPU. So those particular transaction, we have basically two types of transactions there. Let's say low bandwidth transaction and high bandwidth transaction. Okay, so you are aware of XI protocol, everyone, or
Yes, I and I work with
okay.
ISI.
So let's say we have some XI protocol. So we have those a single beat transaction and multi beats transaction in that. Okay. So the low bandwidths we have, let's say we have a CPU, we are accessing from CPU to the low bandwidth space. Let's say registers, low bandwidth space, you can take it as a register access. Okay, inside the IP. So from the CPU, we initiate those transaction and we debug like it passed through some routers. I think in previous lecture you were aware of those routers interconnect between that, right? Am I right? Or you have that knowledge for routers or?
Yes, sir.
Yeah, okay. So we have the routers. If anyone don't know, we have some routers in between the different IPs that route the transaction uh, towards a specific targeted IP that we are accessing. So this is the router role. So we have different fields or IDs, user fields to control this particular where this transaction should route. So this particular debugging in the SOC level, we will debug like how the transaction propagate from CPU and pass through the routers from different routers we have. So and now reaching to the target IP. So we have this particular debugging that how the transaction is flowing from one component to another component, and so its response is once the request is reached to the target IP. So the response should be going back to the same verification that flow. Uh, so this particular debugging is cover that particular the paths. Okay.
Yes,
So
sir.
till now it's fine.
Yes, Tina is okay.
Okay. Okay. So this is the high level thing, and yeah. So after that, when we have some the vPlan creation and those attributes we have covered. So after that, in IP level also we have the functional and the code coverage there. So in similar we have in the SOC level as well. But the thing is, like in IP level, we check each and every signal toggling. Okay, but in the SOC level, there are lots of signal. You already know we have um, thousands or millions of signals. We can't check the each signal are toggling. Okay, so we just like let's say I take the example of this LBW transaction, the low bandwidth transaction, the register I. So we have let's say 1,000 IPs there. So we check that each path we have covered or not. So this path we check and cover that through the coverage at each dedicated path we have covered or not. So and also some top level pins we can check that they are toggling or not. Like let's say we have some GPIOs there, so those we are covering or not. Okay, so these are some of the points that we cover in the SOC level. Okay, and next we have the gate level simulation that in GLS we also run in the IP level. So on the SOC level also we run and see some internal um, uh, X propagation we have or not, or some timing delays. Okay, some setup and hold time violations we will also find with the real delays when we insert the real delays inside that. So we check those how the SOC will be behave with the real delays with that. Okay, and after when we cover
So
all,
what a timing guide simulation, sir?
which one? Yeah, timing and gate level simulation is like that I mentioned, like we have some setup and hold times. So let's say we have previously in the normal simulation we are using the RTL, okay, and in this GLS what we do is we replace those gates. We have some gates, okay, inside any RTL. So we replace those gate with the real time, how much time that particular gate will take, okay. So this will create some setup and hold violation. So in GLS we generally, this timing and gate level, we will generally check uh, those particular stuff, like is there any timing issues is there or not. So yeah, so is it clear?
Yes, it's clear, sir.
Okay. So next we have that we complete this VPlan attributes and all debug paths and some code coverage, functional coverage, and this gate level. So next we have the sign off criteria. So what the sign off criteria we have is like we have some checklist there actually. In that particular checklist we have some points they have mentioned, like we have all the tests are in the regression and all with different seeds we have checked, and some X propagation we have checked, some memories we already verified, some memories we have to, and some code coverage and function coverage we have reviewed with the designer. So those stuffs we have some checklist. Every project actually they provide some checklist, so we have to cover those things in this sign off criteria of SOC level. Okay, so this is the high level view, and now we will talk about like uh, what we will attributes, what type of attributes actually we will check in the SOC level thing. So we'll go over the high level points. Okay, so what type of attributes we will check in the SOC level is first of all, like we have the connectivity things, like I mentioned in the previous slide also. Like let's say we are accessing some low bandwidth path from CPU to the dedicated IP. Okay, so we check the connectivity. Let's say it passed from the router, so it is passing from the correct router and it is going to the targeted IP or not, and the response is routing back from that targeted IP towards the CPU. It's towards the CPU or from IP to IP. We also check, like let's say we have the PCI is accessing the video IP. Okay, so those stuffs is there. So this bus connectivity will check, and the register write read we also check. This is the basic things that low bandwidth path we will capture through this. So this register read write uh, is ensure that the LBW routing is uh, properly handled. Okay, so this is for the low bandwidth, and one we have the high bandwidth path as well.